This video will show an example of the new Fabric AI skill, which is in public preview at the time this video is recorded. Fabric AI skill is a Saas, which means software as a service, tool for creating a RAG, which means Retrieval Augmented Generation, chat interface over your data that I would describe as being similar to ChatGPT with your data or an AI agent for analytics. And for the end user, it provides them that experience without having to write code. Here's a few examples of what the AI skill can show using public open data from CMS. Show top 10 ACE inhibitors by total cost prescribed by internists in Texas in 2022. Show total cost for quinolones in Minneapolis, Minnesota by year. Show cities on rows and total cost of ACE inhibitors, total cost of ARBs, and total claims on columns where the year is 2021 and the state is Michigan. Everything you see in this video is built on 250 million rows of real CMS Medicare Part D healthcare data that is available to the public. You can deploy everything in this video using a free GitHub repo, and all you need is a Fabric-enabled workspace while using Microsoft Fabric. A link to the GitHub repo with instructions for deploying everything you need to try this out yourself is in the description. My name is Greg Beaumont, and I currently work in Microsoft's healthcare vertical as a technical specialist for data and AI. If you find this video helpful, please give it a thumbs up and follow the channel. So now I'm going to give a brief overview of how to deploy this Fabric AI skill from the GitHub repo to your own environment, and also discuss why it is of value, and from my perspective, how it's a game changer that is effectively an AI agent over your data in Microsoft Fabric. I'll provide a link to the main repo in the comments below. For now, I'm showing a branch of my updates that have not been pushed to the main branch yet. But here at the highest level of the repo, you can click on the first module, which is for Analytics, BI, Direct Lake, Star Schema. And we have several other videos that can walk you through how to deploy everything here. You should be able to get it up and running in less than 2 hours with minimal code. And in addition to the AI skill that I'm going to show you, it'll also give you a lot of other capabilities within Fabric that you can test on 250 million rows of real data. Scrolling down through the process, effectively what this solution is doing is pulling data from the source servers, which provide public data from CMS, and then prepping it for use inside of your Microsoft Fabric environment. For the demo, I'm going to show the version which uses the warehouse within Fabric as the gold layer. And moving down, it goes through all the steps on how to deploy everything. And what I'm showing in the video is for option 2B, but everything should also work with option 2A if you'd prefer to use the Lakehouse. Down at the bottom of the page, step 5, which is new to the repo, is to create the Fabric AI skill. Go ahead and click on that link. Here we have some instructions on how to create the Fabric AI skill. You can read those yourself. I will go ahead and show a quick demo on how to quickly deploy it to your environment. Here within my Fabric workspace, up at the top, I can click New Item. From here, I can select AI skill, which you can see is in public preview at the time of this recording. Let's give it a name. Hit create. Now you'll see you have the option of selecting either a lakehouse or a warehouse from your environment. I'll go ahead and select the top warehouse, hit confirm. And now I get the option to select the different tables that are within that warehouse. For the examples, we're going to select all 5 of the tables from the star schema that was created using the GitHub repo. So the drug table, the geography table, the provider table, the year table, and the fact table. If you were to expand this caret, you'll see the column names and the data types of everything that's in that particular table. Once you've selected those 5 tables, click on Get Started. And now at this point, technically you could just start asking questions. However, I wouldn't recommend that unless you just want to see what the response accuracy is working with your raw data. When you type a question in here at the bottom, the AI skill will attempt to translate that into a SQL query that gets passed back to these tables on the left. However, if it doesn't have any context as to what the question actually means, the queries might be a little bit goofy. So over here on the right, as you'll read in the instructions in the GitHub repo, I walk you through a process to add some notes for the model, which effectively work as a system message in a RAG model that instructs the large language model as to what the different columns mean, how the different SQL statements should be put together, and contextual information that you might call unstructured metadata. And then down at the bottom, there's also the example SQL queries that actually show it how to write the SQL properly in order to get the desired results. Up at the top, SQL query variations. I won't dig into that today, but effectively the more variations you have, the more work it'll do on the back end to try to get the right answer, but it'll also theoretically use more compute. And you can also choose whether or not you want to see the SQL query that was written in order to generate the result. For the purposes of walking you through how everything works today, I'm just going to leave that turned on. But if you were deploying this as a tool to end users where maybe they're accessing it through Teams or some other type of interface, you might not want them to see the SQL query. You might just want them to see the results. So before I go ahead and enter in the notes for model and the example SQL queries, I want to show you what happens if I ask a question without any of that contextual information. So if I put in show top 10 ACE inhibitors by total cost prescribed by internists in Texas in 2022, hit go. And you'll see that it comes up with empty results. What it actually tried to do here with SQL is select top 10 of drug cost, which was correct, but then it assumed that the brand name was ACE inhibitor, and the word ACE inhibitor doesn't appear anywhere in the database. The brand name is the actual brand name of the medications. ACE inhibitors are a class of medications. It assumes that internist meant prescriber type, and it looks like it actually did get the state correct, along with the year. However, the results are empty because it couldn't quite figure out how to filter for ACE inhibitors and for internists. Now, let's go back to the repo, and following the instructions, the next step is to enter the notes for model. So let's go ahead, copy those notes, and before we paste them, let's just walk through what this is doing. I want to clarify here, I'm not claiming that these are the best possible notes in order to create this AI skill. This is just an example that I got to a certain point where it was working well enough to push it out. I do anticipate that I'm going to modify it in the future, make it better, maybe account for things that aren't working quite right. And if anybody has any advice on how to make it better, or if you take this and make it better, please pass it along and we'll add it to the repo and make sure that we give you some props for that. But you'll see that the notes walk through what is the drug table, what is the provider table, what are some synonyms that might exist for those different columns, the context of the year table, the geography table, where, for example, one of the instructions is that state abbreviation should be used for queries about states or a U.S. state. States are abbreviated with a capitalized 2-letter abbreviation such as MN or WI. This will then instruct the AI skill or the large language model behind the AI skill on what to put in the SQL query when asked about a specific state. There's some context about the different columns in the fact table. And then at the bottom, there's also some information on key classes of drugs. From my perspective, this is one of the game changers of AI skills because in the past, if you wanted to add a filter for ACE inhibitors to a database that does not specify which drugs are ACE inhibitors, you would either have to create a new column to your drug table, potentially a separate table that snowflakes off of that table and does some filtering context, or perhaps write some very complex queries in order to enter the filter context on the back end. So having the ability to have some unstructured instructions that effectively give you filter criteria that can then be used with natural language query is extremely powerful. So for example, you can see that all ACE inhibitor drugs contain pril within the generic name. All quinolone antibiotics, also known as quinolones, will contain fluoxetine. Also some information about specialties, such as internists or internal medicine, will contain internal medicine within the column prescriber type. So this is how the large language model will know that when somebody asks about internists or internal medicine, that they should actually use the filter criteria for internal medicine as it is spelled here in order to generate a proper query. So let's go back to the AI skill. Let's paste this into the notes for model. Then let's move down here to the example SQL queries. Moving back to the GitHub repo, let's go back to the previous page. I've already downloaded the JSON file, which is here in the GitHub repo that has those example queries. I'll go back to the AI skill, hit the little pencil, import from JSON, select the JSON file that I just downloaded, hit open, and then we have some example queries that can then be used in the AI skill. Again, I'm not claiming these are 100% right all the time. I'm not claiming that these are the best you can possibly do. I'm just giving you a starting point in order to learn how to use this tool and see what it can do. And again, if you come up with even better queries that can be added for these examples, please pass them along and we will add them to the repo. So one example here would be show top 10 doctors in Florida for total cost of statins. So the query here in SQL is select the top 10 doctor names, sum up total cost. And let's just expand this so we can read it. Joining the drug table, the geography table, and the provider table, and look for drugs that contain statin in the generic name, and FL for the state abbreviation, and then you have your group by and order by. So effectively, you're using natural language over here on the left, and the AI skill will know to translate Florida to capital F, capital L, and statins to looking for generic names that contain statin within the column entry. Another example would be show total cost percent change for 2021. And this is giving an example of how year-over-year percent change can be calculated in a way that should work. And it's effectively saying, select the sum of cost for the year 2021, subtract the total cost for the year 2020, and divide by the year 2020's total cost. And there's also a conditional null if in there so that if 2020 was null, it's not going to throw an error when it runs the SQL statement. So now that we have those uploaded, you can go ahead and go back to the AI skill. And let's run that original question again and see what kind of an answer we get. Show top 10 ACE inhibitors by total cost prescribed by internists in Texas in 2022. Now this time we get answers. You can see we have ACE inhibitors on the rows and we have total cost on the columns. And it appears that they are ordered descending based on total cost. Looking at the SQL query that was generated, you can see that it now knows that ACE inhibitors mean that there is PRIL in the generic name, TX is the state, and internal medicine is the filter criteria for the prescriber type, along with 2022 for the year. Let's try another one. Show total cost for quinolones in Minneapolis, Minnesota by year. And there we go. We have total cost by year, and you can see that it even understood the context of the city and state. Let's do another and make it a little bit trickier. Show city on rows and total cost of ACE inhibitors, total cost of ARBs, and total claims on columns where the year is 2021 and the state is Michigan. Here we have some results. You can see there may be an error in the data. It's giving what looks to be an address rather than a city, but the rest do look like cities. Then you can see the total cost of ACE inhibitors, total cost of ARBs, and total claims. And if we were to look at the SQL query that was generated, it's filtering for the correct state, which is Michigan, the correct year, which is 2021. It is summing up total cost correctly. It's summing up ACE inhibitors correctly, summing up ARBs correctly. Sartan is contained in the generic name. And then it's also summing up total claims. So there might be some more work I could do in the example SQL queries to have the correct formatting where, for example, cost comes up with a $sign in front of it. And I'm sure there's a lot more example queries that could be added for enriched context, but hopefully this gets you off on the right track. And again, once you have the entire GitHub repo deployed to your environment, let me go ahead and move back to that landing page. The whole process of getting that warehouse or lakehouse stood up should be less than 2 hours. And then the whole process of building out this Fabric AI skill should take about 10 minutes or less. So once you have that lakehouse or warehouse available, you just check the 5 tables, decide what you want to do with SQL query variations. If you want to show the results of the SQL query, paste in the notes for model, upload the SQL queries, and then you can begin asking questions. And then based on the results, you can go back and experiment with changing the notes and changing the queries to see if it gets you better or degraded answers. Again, if you like this video, please give a star to the GitHub repo, a thumbs up to the video, and if interested, follow the channel for more similar content in the future.